Yes, I do have some very, very nice things here. Do you recognize these?
Oh, I know what they are. I love to grow them. Are they?
It's a
Are
shame
Yes,
it's
they?
not shame it's not smell-o-vision. Hey, Joseph.
I know they are
yes,
beautifully gorgeous to smell. I'm
I
very
agree.
envious of you
I
right now. Are
Yes,
they what we would call in the UK sweet peas? I don't know if you
yes,
call
we
them the
call them
same thing over
sweet
there.
peas
Yeah,
here
very
as
good.
well. Yes, yes, they are sweet peas and they're very fragrant. A little bunch like this is enough to give fragrance for a whole room.
Yeah.
And I used to live in a place which was a little bit more where there were more people because it was actually on the campus of a little Bible college, and along the front path going past my little place. I used to grow sweet peas, and I used to love to watch people. They'd walk along, and then they'd slow down and take a few deep breaths, and then move on, because they would really enjoy the fragrance of the sweet peas and enjoy the color as well. They come in lots of lovely colors, and this is by no means the full variety of colors that you get them. It's just these are the ones that are in bloom at the moment, and they are lovely and fragrant. Now, the skeptics who scoff at us and say we're just being sentimental and silly, us Christians, they say, oh, flowers have just have color and fragrance because they need to attract insects in order to pollinate them. Uh, well, that's certainly true for some flowers. I've got a few more flowers here. Now, these, let me just hold them a little bit closer. These ones here that you can see, these are a type of small lily, and they are very well designed for insects to land on them. And you can see it's a sort of open flower that's upright. And if I just hold it a little bit closer, you may be able to see the pollen, which is on the ends of the little stems inside the flowers. Can you see that?
I think we're just
Yep.
Maybe,
about to see that. Yeah, there we go. Lovely. Yeah,
yeah, yes. I think that one there,
that's
you can
nice and
see
clear. See
the
the little dark
little
bits. Yeah.
blobs of pollen. Yes. Okay. So this is a well-designed flower for insects to land on. It's a nice light color, so it shows up quite clearly. But let me go back to the sweet peas. Now, can you see any pollen in these? If I turn them around, particularly these light-colored ones, can you see any pollen?
Nope.
No, no. All right. Yes, they have color and fragrance, but we can't find any pollen. And if a bee lands on this, and I have seen this happen, a bee will just land on this and then it will fly away. Uh, Whereas if a bee lands on one of those lilies or on some of the other flowers in the garden, like the lavender, the bees will stay there and move about and collect the pollen and drink the nectar. Now, I've also got another kind of flower here that's, let me just pull this one up. Do you recognize that?
Hmm.
Um, the light
Oh,
is a bit off.
is that the little snapdragons?
It's a snapdragon, yes.
Yeah,
Now, can you see any pollen in this?
not at all. No,
Sorry, the
nothing
light's
on the surface.
not that brilliant here. It just, I
Can't see
happen
them
to
at
like
all.
this very dark color because it's lovely and velvety. It reminds me of
Mm.
velvet, but and I'll talk about that later. Um, just doesn't show up terribly well in this light. Now, these do have pollen, um, and if you just give them a gentle squeeze, uh, can
There's the
you see
dragon.
there? Right, the pollen is inside it. Uh, but how is the bee to find that? Because when the flower is just growing in the garden like this, you can't see that. And in fact, these ones do need bees to pollinate them. The interesting thing is, sweet peas do have pollen, and because they're so small, it's better if I show you some photos that I took of them. Yes, let's have a look at sweet peas and snapdragons, because when you see them growing in the garden, you can't see any pollen, but they do need to be fertilized, just like any other plant. So here we go. Here are some sweet peas and some snapdragons. Sometimes the snapdragons are called antirrhinums. And they do look similar to one another in structure and in shape and color. but they're quite different in the way that they actually work. So let's try the sweet peas. First of all, here are some sweet peas that are still actually growing in my garden before I picked them. And where's the pollen? Well, if we take one inside, we can have a closer look at it. So if you take one inside and have a look, hold the flower up, you can see that there is those two petals at the top, and then there's a sort of curved crescent-shaped structure at the bottom there, which is actually enclosing the pollen. So even if a bee lands on this, it can't get any pollen. And just to show you, I've actually opened that up, and you can see there is pollen in there. Now, the bee does not actually open that up. In fact, the flower fertilizes itself inside that enclosure. When it has fertilized itself, the flower will just wither, and that will all fall apart, and it will form seeds, and you will get a new crop of sweet peas without the help of any bees. Now, that's interesting. So why do they have color and fragrance? Well, from my observations, that it certainly attracts people, not so much bees, but it works. It's a piece of really clever design. Now, so sweet peas have color and fragrance, but they don't need external pollinators. They are a well-designed flower, and they work, but not in the way that the skeptics would like to say, oh, well, they just must have evolved that way because they needed pollinators. But then you should ask the skeptics, well, the fragrance is actually quite a complicated chemical, and so are the colors and the shapes. And to go from a just general round flower to an odd-looking flower like that requires a lot of genetic changes. How would that happen all by itself? So let's move on to the snapdragons, which come in all sorts of lovely bright colors as well. They're not as fragrant, but they do have an interesting shape and an interesting texture on them. And so these do need to be pollinated by insects. But because they're such an odd shape, you wonder, well, how on earth is an insect going to get to the pollen of these? In fact, they are extremely well designed. And remember that fun thing that you used to do with snapdragons, you hold them on either side and give them a bit of a squeeze, because the top and the bottom part of the flower are connected together by a little hinge. And so when you give them a squeeze, or if an insect lands on one, that hinge actually opens and exposes the pollen. So these are pollinated by bees. In the UK, they're pollinated by bumblebees. Bumblebees really love them. We don't have bumblebees here, but honeybees and other bees will pollinate them, and they will land on the flower and push their head into it, and the flower will open with that little hinge, and then they can get the pollen and the nectar. Now, because they have such an odd shape, there's a bit of a problem for the bees. So here is a bee flying up to a spike of snapdragons, and because they grow vertically like that, unlike the lily flowers that I showed you in the beginning, which are a nice cup shape for the insect to land on, this is a bit of a precarious landing, particularly as the bee has to sort of push its head into the middle of the flower. And the interesting thing is they've looked at these flowers under an electron microscope, right? So this is right down to the very, very microscopic size. And they've done some interesting research, and they've found that the normal flowers, what they call the wild type, the ones that just grow in the garden or grow anywhere else, the surface cells on their petals have these distinctive cone shapes. And in order to investigate why this is important, they've actually grown some mutant flowers which don't have these. They have flat cells. So that's the photo that's there labeled B. This is out of the scientific journal PLOS One, from a series of papers investigating how snapdragons work and how they interact with their pollinators. So in fact, the cone-shaped cells on the surface provide a nice matte surface, which helps the bees grip onto them so they can land on the flower and push their heads into the flower without slipping off. Now, they've done research into other flowers as well, common garden flowers like petunias and lots of other different flowers. And they also have these cone-shaped cells that give them a nice velvety surface when you look at it, and you see these distinctive cone shapes when you look at it under a microscope. So that's a piece of neat, clever design. The flower gains nothing from having these cone shapes, but the bees certainly do. And then they did some more interesting research, and they found that the cone-shaped petals actually help the flower absorb solar heat. So the flower warms itself up, and it turns out that bees prefer warm nectar. So if they land on a warm flower, they drink the nectar, and that's good for the bees as well. Now, you have to think insects being very, very small for their size and shape, they actually have quite a large surface area and they do lose heat quite easily. So having a drink of warm nectar is good for the bees. Now, quite a number of years ago, I was listening to one of the botanists who has done some of this research into the way flowers and bees interact, and in particular with snapdragons because of their complicated shape and their interesting surface properties. And it was on a program on the ABC, which is like the equivalent of the BBC. And it's called The Science Show. And I was listening to this botanist, and she made this statement. The implication that we're really most excited about is that flowers are cleverer than we thought they were. Now, I don't know about you, but I think that is a rather stupid statement. Who ever heard of clever flowers? There's no such things as clever flowers, right? These are well-designed flowers to be part of a well-designed system. So not clever flowers, right? Instead, a clever creator who creates things that are functional and also beautiful. And that's part of the very good world that God made in the beginning. If you read through Genesis 1, there's a repeated phrase that God declares what he had made was very good. It's very functional, it works, it's very clever in terms of flowers and insects, well designed to interact with one another, but it's also beautiful. And then you read in the next chapter that when God planted a garden, he filled it with plants, with trees particularly, that were pleasing to the eye and good for food. So this was when he was still creating, and he declared that at the end, when it was all finished, that was very good. So the very good world was functional and it was beautiful, designed as the perfect place for human beings to live. And we're still enjoying that when we enjoy the fragrance of sweet peas, when we enjoy the fun shapes of snapdragons and squeeze them and open and close them, and when we watch the bees come along and pollinate the flowers and take advantage of the well-designed flowers designed just for them to work best.